Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 3 video from the chapter of energy, where I will discuss about the energy, particularly two forms of energy, that is gravitational potential energy and kinetic energy, and how gravitational potential energy is transformed into kinetic energy and vice versa. This video is part of the playlist ICSE Physics for Class 8, where primarily I discuss about the key concepts and formula related to numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case, do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 3 video where I will discuss about gravitational potential energy and kinetic energy. Okay, so first of all we need to know what is meant by energy. Now in physics, energy is defined to be the capacity to do work. When you do work, then obviously you must have some energy that is making you capable of doing some work. So work is done utilizing some energy. When you let's say when you displace an object, we apply a force on an object and the object is displaced in the direction of the force, some work is done, and that some work is done, we know it is force multiplied by the displacement, and that work done is equal to the energy that was spent by you. That is, you lost an energy which is equal to the work you have done. So essentially the unit of work and energy, they are same. They are same. Okay, now another important thing is that law of conservation of energy, which says that energy cannot be created nor can be destroyed. It can only be transformed from one form to another form of energy. Now there are various forms of energy. Since the primary objective of these videos is to solve numerical problems, I will not touch much about the theoretical concept. There are various forms of various forms of energy. Two important being potential energy and kinetic. Two important being one is mechanical energy, and under the mechanical energy you have potential energy and kinetic energy. And there are other forms of energy like electrical energy, heat energy, light energy, which I will not discuss. Okay, so when some work is done at the cost of some, when some work is done, that work is done at the cost of some energy. That is, some energy was consuming some energy, some work was done. And if a work was done on some body, that body will also gain some energy. So this is what it is saying, that work done is equal to energy consumed. That is, if somebody is, let's say, if somebody is pushing a block of, is pushing a body along the ground, and let's say the ground is frictionless, and the person is applying some force, and since the ground is frictionless, the body that force will cause the body to move, and the body will gain some velocity. So in that case, in this case, the energy gained by the body will be its kinetic energy, which is half mv square. Now the body gained this kinetic energy from where did this now this kinetic energy was not created out of nowhere. This kinetic energy is basically the transformed energy, and that energy from which energy was this kinetic energy created. It was the work done, or the person who applied that force, his energy was consumed. That energy is equal to the kinetic energy of the body. Okay, so as you can see, this is there is a big hierarchy of different forms of energy, and one form of energy can one group of form of energy is mechanical energy, under which there are two types of mechanical energy. One is potential energy and another one is kinetic energy. Now potential energy are of two types. One is gravitational potential energy, which is due to the state of rest or position of a body having some mass, and the other form of potential energy is the elastic potential energy. For example, when you stretch a spring, if you leave it, it comes back. Or let's say if you tie one end of a spring, let's say one end of a spring is tied to some ground, and let's say and on the other end there is a ball, and if you compress the spring and leave it, you will see that the spring will tend to retain its original position and the ball will fly upwards. So these are examples of elastic potential energy. Also, when you stretch a rubber band, then also when you stretch a rubber band in the stretched position, the rubber band is said to have some elastic potential energy. So this is potential energy. Another form of mechanical energy is kinetic energy, which is primarily due to a body in having a velocity and some mass. So if a body of mass m is in motion with the velocity v, then its kinetic energy is half mv square. Okay. Now, when a body gains some potential energy? So typically, when you lift a body, let's say there is a body of mass m kilogram, it is on the ground, resting on the ground. If you pick this body up and lift it to a height of h meter, then the body will gain a gravitational potential energy which is equal to mgh. Here g is the acceleration due to gravity near the surface of Earth, which is 10 meter per second square. So when a body the concept is when a body gains a height, when a body of mass m kilogram gains a height of h meter, then it gains a gravitational potential energy of mgh, where h is the height by which it was lifted up, m is the mass of the body, and g is the acceleration due to gravity. Now when the body was resting on the ground, its height was 0. So the potential energy, which is denoted by the capital letter U, was 0. And when the body was lifted, in this position, when the height of the body from the ground is h meter, it will have a gravitational potential energy of mgh. Okay, this is the basic concept. Now regarding the kinetic energy, let's say there is a body m kilogram of mass m kilogram on the ground. Let's say at the position A, the body is at rest on the ground, that is, its velocity u is 0. So its kinetic energy of a body is defined as mathematically is half mv square, where m is the mass of the body and v is the velocity. So at the position A, the kinetic energy of the body will be half mu square, but since u is 0, it will be 0. So a body of whatever mass it be, if it's in rest, its speed is 0, its kinetic energy is 0. Now let's say at the position B, the body has attained some velocity. Let the velocity be equal to v, that is u is equal to v. Then the kinetic energy of the body will be half m u square, which is half m v square. Now typically the kinetic energy of a body is usually gained because it loses some gravitational potential energy. So the transformation of energy from gravitational potential energy to kinetic energy and vice versa is very typical and is very typical in real life scenario. So let's try to understand how gravitational potential energy is gets converted to kinetic energy and vice versa. Okay, so I will take a very typical example. Let's say there is a body of mass. Let's say a body of a body of mass m kilogram is dropped from the position A, let's say the position C is ground, that is the position C is at height 0. Let's say a body of mass m kilogram is dropped, and definitely it will fall due to the force of gravity, that is due to gravitational pull, that is due to its own weight, which is mg. It will fall. Let's say it is falling in the straight line, and it is passing through the point B. Okay. Now let's try to understand what will be the potential energy and the kinetic energy at these 3 points A, B and C. At the point E, the body was at a height, let's say this height, the height of the position A from the ground is, let's say, h meter. Let's say the height of the position B from the ground B, let's say, just for the sake of discussion and understanding, let's say the height of the point A from the ground is capital H meter, and the height of the point B from the ground is small h meter, just to indicate that h is obviously greater than small h. Okay. Now, okay. Now, at point A, the energy that the body is having is only due to its position. That is, it is at a height h, capital H meter from the ground. All the energy it has is the gravitational potential energy. Now, so gravitational potential energy, or in general potential energy, is denoted by the letter capital U. So at the position A, U will be equal to mgh, will be equal to mhg, where mhg, where m is the mass of the body, m kilogram, h is the capital H is the height of the position A from the ground, and small g, where you can consider small g to be either 9.8 meter per second square or 10 meter per second square. So this is the potential energy or gravitational potential energy the body is having at the point A. Now what will be the kinetic energy? Kinetic energy is usually denoted with Ke. Since when the body was dropped from the position A, it was not in motion, it was at rest. So if a body at rest will obviously have no velocity, so its kinetic energy is 0. Or more precisely, half m, the velocity is 0. This is equal to 0. Now I am denoting the letter E to denote the total energy of the body at any position, that is its gravitational potential energy plus kinetic energy. So at point A, the total energy will be U plus kinetic energy. U is m h g. Remember, U is mhg. This will be joule. By the way, the unit of energy is also the same as the unit of work done, which is joule. Okay. So at the position A, the total energy possessed by the body will be its potential energy U plus its kinetic energy Ke. Potential energy is mgh joule, and its kinetic energy is 0 joule. So this is equal to m h and g, this much joule. Okay. Now let's see what will happen at point B. At point B, definitely it has lost some height. It has come to a point B, position B, where the height is now small h, which is less than capital H. So at point B, what will be its potential energy or gravitational potential energy? It will be m small h, and g, this much joule. But small h is less than capital H. So the potential energy at the point U is definitely less than, okay, let me, for the sake of better understanding, let's say UA be the potential energy at the point A, and KEA be the kinetic energy at the point A, and total EA be the total energy at the point A. So UB is MAGH, which is obviously less than UA, because UA is MH, capital H is greater than small h. So we can see that the body, when it came to the point B, it lost some potential energy, and the loss in potential energy is definitely UA minus UB. Now, from the law of conservation of energy, we know that energy cannot be destroyed nor it can be created. So what happened? The body lost some energy, but definitely the total energy, since from the law of conservation of energy, the total energy of the body, that is E, will always be same. From the law of conservation of energy, I must have the total energy of the body at the position A should be equal to the total position of the total energy of the body at position B should be equal to the total energy of the body at the position C. Now, so UB is U less than A. So the loss in loss in U at B is equal to UA minus UB, which is equal to mgh minus small h, this much joule. This energy, this amount of potential energy was lost. Apparently it seems to be lost when the body came at the position B, but energy was not lost. What happened is that when the body is at B, it is in motion, it has some velocity, and obviously then it will have some kinetic energy, and that kinetic energy is equal to the potential energy that the body lost when the body is at the position B. So let's say if I say let velocity at B is equal to small vb, meter per second. So when the body is at the position B, definitely it is in now motion, it has gained motion, it has gained some velocity, and let that velocity be Vb. So kinetic energy now at the point B will be half m Vb square, that is half m Vb square. This kinetic energy was gained by the body at the position B due to its loss in potential energy. So this should be equal to mgh minus capital H minus small h, joule. Okay. Now, so definitely if you see that what is the potential total energy of the body at position B, EB is equal to UB plus kinetic energy B. UB is m small hg, joule. And what is kinetic energy? Kinetic energy is mgh capital H minus small h j, because the body was in motion, the body gained some velocity, because the body gained some velocity which is the Vb. We are assuming the velocity at the point B to be V, so it gains some kinetic energy which is half m Vb square. Now this kinetic energy the body gained because it lost some potential energy. So the loss in potential energy when the body came from A to B is equal to the kinetic energy that the body gained at the point B. Okay. So now if you sum this up, you will see that this is essentially small m capital H G joule, which is equal to EA. So you will see the total energy of the body will always be same at the at the 3 points ABC. In fact, at any point in the straight line of the motion, you take any point at that position, the total energy of the body will be same, which will be equal to m capital H G joule. Okay. Let's see at what is the scenario at point C. At point C, now at point C, clearly what will be the gravitational potential energy? It is at zero height. It is at zero height. So the gravitational potential energy will be m, the height is 0, G joule, which is equal to 0 joule. So at the point C, that is when the body reaches the ground, it lost all the gravitational potential energy. Now from the law of conservation of energy, definitely all the gravitational potential energy which the body was having at the position A has now been converted into kinetic energy. So definitely has been converted to kinetic energy. So let's say let Vc be the velocity of the body. My machine is running so slow, I really can't write it properly. It's very horrible. Anyway, so let Vc be the velocity at point C. At point C. So what will be the kinetic energy of the body at point C? It will be half mvc square. Now, and this kinetic energy will be equal to now at the point C, what is the gravitational potential energy it lost from A? It is UA, because it is actually UA minus UC. Since UC is 0, it is equal to UA. And what was UA? UA was mH G joule. So we have that at the position C, I am having, if the velocity of the body at the position C is Vc, I must have half m Vc square is equal to m capital H small g small g. So at the position C, the body lost all the gravitational potential energy which was m capital H G when the body was at position A, and all the gravitational potential energy, that is UA, was converted to kinetic energy, which is half m Vc square, and which is equal to m capital H G. So if you are asked that what will be the velocity, if you are given capital H, and if you are asked what will be the velocity of the body when it reaches the ground, you can apply this formula. Vc is the velocity of the body at the position C. Also, if you are asked that what will be the velocity of the body gained at the position B, which is at a height small h, then also you must be able to find Vb from the equation, this equation, that half mvb square is equal to mg capital H minus h. So these are few formulas and concepts that I want to discuss regarding the transformation of between gravitational potential energy and kinetic energy. Based on this concept, I will solve multiple choice problems in the next video. I will not make this video longer. I hope I was able to give some information, some concept and formula as regarding what is energy, how it is related to work done, and what is meant by energy consumed, energy gained, and the potential energy which is that is one form of potential energy is gravitational potential energy, and the which is a form of mechanical energy, and the other form of mechanical energy is kinetic energy. The kinetic energy of a body is half mv square, and when a body falls from a height, how the potential energy and the kinetic energy of the body is changing. Okay, if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. And always feel free to let me know any questions or any doubt regarding any formula concept that I am discussing in these videos, and I will appreciate that, and I will do my best with the best of my knowledge and ability to address your questions. So thanks for watching, and until the next video, take care and bye.